This video is about exponential functions. That is a part of section 4.5. So I would name this video as section 4.5 part 1. So to define an exponential function, it is a function in which variable occurs in the exponent. So let me define it. It is a function where the variable occurs in the exponent. Okay, so we can solve certain exponential functions using the fact that a power x is equal to a power y. So that implies x is equal to y. But this is because we defined exponential functions not to 1 or to 0. Okay, so this particular statement, you saw this statement in quiz 1. So it is not valid if a is taking the value of 0 or if a is taking the value of 1, right? But in definition of an exponential function, we eliminate the possibility of a being equal to 0. So a is not equal to 0 or a is not equal to 1 as well. Correct? So we can use this property to solve the equations. Let me solve a problem for you. I will do an exercise problem, say exercise number 4. You have the question to be find the solution of the exponential equation as in example 1. Example 1 is given in the book, so where we use the technique of using this, if the bases are same and raised to different powers, the powers are also equal. Okay, so e to the power of x square is equal to e power 9. So we know that the bases are same, so applying the strategy discussed above, so this implies x square is equal to 9. So when x square is equal to 9, x can take two values, that is plus or minus 3. So this would be the solution to the exponential equation given in number 4. And I would do another problem for you. This is number 6. So this says that, again you have to find the solution of the exponential equation. So 10 to the power of 2x minus 3 is equal to 1 over 10. So this is not directly related to the method that we discussed above. Like, you cannot see the method being applied directly here. So you have to rewrite this equation as 10 to the power of 2x minus 3 is equal to 10 to the power of negative 1. So now you can see the bases are same, so you can equate the powers. So 2x minus 3 is equal to negative 1. So solving this equation, we get this to be 2x is equal to negative 1 plus 3. So that implies 2x is equal to 2 and x is equal to 1. Okay, so this is the solution. Let us move further. Now I would like to sketch the steps or the guidelines for solving exponential equations. So guidelines to solve exponential functions, that I abbreviate as exponential equations, E or e square. So the first step is isolate the exponential expression on one side of the equation. So isolate the exponential expression or equation on exponential expression on one side of the equation. So bring all the exponential terms on the one side, so that you can apply the rules of exponents, as well as if you have logarithmic properties or nth root properties, you can apply all that and simplify it, because the bases will be same. So apply on one side of the equation. So this is the first step. Second, take the logarithm on each side. Take the logarithm on each side. Then use the laws of logarithm to bring down the exponent. So use laws of logarithm to simplify. Okay, and the third step is solve for the variable. Solve for the variable. So adopting these three steps, we will solve certain exponential expressions. So you can use calculator when you are like using log functions of numbers. So let me do problem number 16 for you. Okay, find the exact solution of the exponential equation in terms of logarithms. And you can also use calculator to find an approximation to the solution rounded to 6 decimal places. So they want the solution to be rounded off to 6 decimal places. So number 16 says that 3 to the power of 2x minus 1 is equal to 5. Okay, so now the first step is isolate the exponential expressions. So all the exponential expressions are on the same side, like or are on one side of the equation, so there is nothing much to do with regarding to the first step. So second step says that take the logarithm on each side, use the laws of logarithm to simplify. Okay, let me take the log 3 to the power of 2x minus 1 is equal to log 5. Okay, so now you can apply the laws of logarithm for this. That is, you can multiply, bring down the power of 3 and multiply it along with log 3, right? So that would be I do not exactly remember which is the property. I think it is property number 3 or law number 3. Okay, so if you apply law number 3, it would be 2x minus 1 times log 3 is equal to log 5. So upon cross multiplication, you get this to be 2x minus 1 is equal to log 5 divided by log 3. But what is this? If you do not have any base, it means to say that you are applying the common logarithm, that is to base 10, correct? So this would be 2x minus 1, and applying the rule, the law number 2 here, you can write this as log 5 minus 3, correct? So this will imply that 2x minus 1 is equal to log of 2. So solving for the variable, we did the second step. What was the second step? Use the laws of logarithm to simplify. So this is the maximum for which, up to which we can simplify. Now we will solve for the variable, that is, the variable is x. So 2x is equal to log of 2 plus 1, and x is equal to log of 2 plus 1 divided by 2, correct? So now if I use the calculator for this, my x value turns out to be, okay, log of 2 plus 1 divided by 2. Okay, it turns out to be approximately equal to, I need 6 decimal places, I know that. So it turns out to be 0.6505149. So 49, as I have, after 4 I have 9, I can approximate it to 5. Okay, 6505115. Okay, yeah, there are 6 decimal number 6 points after the decimal point. This is the solution for the equation. Let me do another problem for you. Say problem number 18. So this is a consecutive problem just right below 16. Okay, 2 e power 12x is equal to 17. This is a problem under the same instruction as of above. Okay, now again you have nothing to do with the step 1, like all the exponential functions are one side of or on the one side of the equation, so you have nothing to do much here. Okay, the second step is to apply log. So log on both sides, 2e power 12x is equal to log of 17. Okay, so this implies you can see a clear product in this term. So if you have to simplify it using laws of logarithm, you have to apply proper law number 1, that is expressing product as a sum of logarithms. So that would be log of 2 plus log of e power 12x, correct? So that is equal to log of 17. Okay, so this implies if you take log of 2 on the other side of the equation, so that would be log of 17 minus log of 2. Okay, so further you can rewrite this term by multiplying the power with the log of e. So this would be 12x times log of e is equal to, and this is a difference of two logarithmic values, so that can be written as log of 17 by 2, correct? So now solving for x, we get this to be 12x is equal to log of 17 by 2, so divided by log e. Okay, and that is x is equal to log of 17 by 2 divided by 12 times log e. So now using the calculator to find out the x value, so 17 by 2 is nothing but 8.5, correct? So log of 8.5 will give me 0.94 and something as a tail. So divided by 12 times log of e. Okay, I'm using a calculator. So this would be approximately I'm sorry. Okay. Yeah, that would be approximately equal to 0.17833 I need, okay, 3388. So I will approximate it to 9. So 6 numbers, 6 digits after decimal point, yes. So this is the solution for the equation. So moving further, solving an exponential, we learned that, and we can even solve exponential equation algebraically as well as graphically. So let us do that. We solved certain equations algebraically. So to solve using a graphical method, suppose you are given say solve the equation e to the power of 3 minus 2x is equal to 4. So algebraic, to solve it algebraically, again there is nothing to do with the, you just have to follow the guidelines or the 3-step rule that we discussed above, and using which we solved 2 problems. So we will do the same for this to solve it algebraically. So e to the power of 3 minus 2x, all the exponential terms are one side, you don't have to do anything here, and apply logarithm. E to the power of 3 minus 2x is equal to log 4. So that will imply 3 minus 2x times log e is equal to log of 4, correct? So now solving for x will give us 3 minus 2x log of 4 divided by log of e. Yeah, one thing that I would like to mention is you can see in all my videos I tend to do all the steps, like I tend to show all the steps, like every working that I that I do, and I do not skip steps, even though it is like pretty simple. So I suggest you to do that, do the same for your exams as well. And I see most of you, like many students, they tend to skip the steps. So it is not like, you may know how to do the steps, but it is not like you're showing the grader that you have understood the concepts, or that cannot be done in the exams for you to get full points. Okay, so solving for x will give us 3 minus of log 4 by log e is equal to 2x, correct? And this implies x will be equal to 1 over 2 3 minus log 4 by log e. Okay, so now you have to use a calculator for this. So log of 4 divided by log of 2 is 2. Sorry, log of e, right? Oh, I'm sorry. Okay, it was log of e. Okay, so that was some 1.36 or something. So 3 minus the answer would give us 1.6137 and something, divided by 2 will give me approximately 0.807, or approximating the third decimal number. So I can write it as 0.807. Okay, so how do we do this graphically? Graphically, we graph the equations. You can see one side of the equation to be y is equal to e to the power of 3 minus 2x, and the other, that is the right hand side of the equation, as y is equal to 4, right? So, and see where these two graphs meet. So that would be the solution. So what do you mean by this expression equal to this 4? So that means that the graphs have a common solution, correct? These two graphs have a common solution. And how do you look for a common solution between two graphs? Like pictorially, or after you look at the graphs, it is where these two graphs meet, right? So depending on the graphing calculator for this, I would like to graph the both the equations. So y is equal to e to the power of 3 minus 2x. Okay, the one in the blue color represents the first equation, and the second one would be y is equal to 4, right? Okay, so you can see the red line meeting the blue line at this particular point. Let us see what are the coordinates exactly. So the x coordinate is 0.8068 and something. So that was approximated for 0.807. If you remember, while we did it graphically, algebraically. So this is how you solve things graphically. Let me do another problem, that is an exercise problem for you. Exercise number 2022. Okay, so there is, solve equations graphically. I do have stuff. Okay, so this is problem number 76. So which says that e power x square minus 2 is equal to x cube minus x. So I think this is of a quadratic equation type, so I still haven't covered this. Okay, let me try exercise number 21. This may be similar to that of your homework problem itself. I will do that. Okay, exercise number 21. we have to do both, like solve it algebraically as well as graphically. That is e power 1 minus 4x is equal to 2. Okay, this is pretty simple, very similar to the above example that we did. So following the guidelines, the three-step guidelines to solve the exponential equations that we discussed in the beginning of the video, there is nothing much to do with the first step again, and apply logarithm on both the sides. E to the power of 1 minus 4x is equal to log of 2, correct? So now yeah, applying laws of logarithm, we can write this as 1 minus 4x times log e is equal to log of 2. So it is like exactly similar, maybe the coefficients are different. Okay, so 1 minus 4x is equal to log of 2 divided by log e. So that implies 1 minus log of 2 by log e is equal to 4x, and this x will be equal to 1 over 4 times 1 minus log of 2 divided by log of e. So it's pretty same, where we divided by 1 over 2 in the previous one, and you had log 3, I guess, or log 4 in the numerator. Here you have different numbers. So log 2 divided by log e would give me 0.693 and something. So, and 1 minus answer would give me 0.306, and that divided by 4 will give me approximate value would be 0.0767. Yeah, I would like to stop it here. So graphically, if you go back to the graphing calculator, I have my e to the power of the first function to be e to the power of 1 minus 4x, okay, and the second function to be y is equal to 2. Okay, so this is the point. Oops, I'm sorry. Yeah, okay, this is the point where yeah, the 2 points are very closer, the intersection point as well as the y-intercept. So I'm not able to show it to you touching the point exactly. Okay, so it is like very closer to 0, you can see that, right? So our answer is also very closer to 0, that is 0.0767. So we are right with that, and that's how you solve the exponential equations graphically. So moving further, if the exponential equations are of the form of a quadratic equation, so what can we do? Let us see that. An exponential equation of quadratic type. So that is, if we have an equation of this format, that is e to the power of 2x minus e to the power of x minus 6 is equal to 0. So again, follow all the guidelines, the 3-step guidelines. What we can do here is bring all the exponential terms on one side. That is already done, and e to the power of 2x can be written as e to the power of x whole square, right? So minus e power x minus 6 is equal to 0. So now substituting e power x as one variable, like say a variable w for that matter. So we can do that. This reduces to a simple quadratic equation, correct? So you can do in this method as well. So what do we get after factorization? We get this to be w minus 3 times w plus 2 is equal to 0, where w is e power x minus 3 times e power x plus 2 is equal to 0. So when will the product of two expressions be equal to 0? When either one of them is 0, right? So to obtain the x value, this implies e power x minus 3 is equal to 0, or e power x plus 2 is equal to 0. So this implies e power x is equal to 3, or e power x is equal to 2. So now to solve this, if you apply logarithm on both the sides, so or express this as using the definition of natural logarithm function, so what do we get? Ln of 3 is x, correct, and ln of 2 is also x. Sorry, negative 2. Oh, I'm sorry. Ln of negative 2 is equal to x. But you do not have the natural log or logarithmic functions defined for a negative number. So this solution is totally ruled out. So we just consider one solution, that is, ln of 3 is equal to x. Okay, this is the solution of the equation. Okay, so now we can try doing, say, problem number 30. Okay, say problem number 40 in the book. We have this to be e to the power of 2x minus, oh, this is like, is it the same? Yeah, it's pretty much the same. Okay, I will do it to be e to the power of x plus 15 e to the power of negative x minus 8 is equal to 0. Okay, yeah, so to do this, e to the power of x plus 15 divided by e power x minus 8, this is written in this format, and taking the LCM, this would be e to the power of 2x plus 15 minus 8 e to the power of x, and you have 0 on the right hand side, so you can multiply the denominator, like after cross multiplying the denominator vanishes, so the equation reduces to just this format. So now substituting e power x is equal to w, what do we get the equation as? So w square minus 8w plus 15 is equal to 0. So this can be written solved using trial and error method, that is 8 can be written as 5w minus 3w plus 15 is equal to 0. So upon solving, you get this to be w minus